Assalamualaikum and good day. Welcome back to BQS 552 Construction Technology 4. We are going to continue to learn Chapter 1 Earthwork. Let's go. Recap from our previous class, we have learned the definition of earthwork and general consideration that must be considered before the commencement of earthwork. Today, we are going to look into the techniques of excavation and their choices. There are 5 of them. First is bulk excavation. Bulk excavation is defined as groundworks which remove large amounts of materials and reduce the general level down to near formation. It includes the following operation, which are cuttings, cut and fill areas, basement and large pits, and hand excavation. Let's take a look one by one. First operation for bulk excavation is cuttings, commonly done for the construction of canals and roads. The selection of plants always depends on the quantity of soil to be transported, the distance of disposal unit of soil, condition of ground and water level, and these are the example of plant use. The first plant that we have here is Backhoe. These machines are suitable for trench, foundation and basement excavation and are available as a universal power unit based machine or as a purpose designed hydraulic unit. They can be used with or without the attendant haulage vehicle since the spoil can be placed alongside the excavation for use and in backfilling. This machine will require a loader transport vehicle for travel between sites. Backhoe used in trenching operations with a bucket width equal to the trench width can be very accurate with high power rating. For Bulldozer, this machine consists of a track or wheel-mounted power unit with a mold blade at the front which is controlled by hydraulic ramps. Many bulldozers have the capacity to adjust the mold blade to form an angle dozer and the capacity to tilt the mold blade about a central swivel point. The main functions of bulldozer is actually for the shallow excavation up to 300 meter deep, either on the level of ground or side hill cutting. Other than cutting purpose, it can be used for clearance of shrubs and small trees. Clearance of trees by using a raised small blade as a pusher arm. It can also be used as towing tractor and can be acting as a pusher to scraper machines. Next plant is trencher. A chain trencher cuts with a digging chain or belt that is driven around the rounded metal frame or boom. It resembles a giant chainsaw. This type of trencher can also cut narrow and deep trenches. The angle of the boom can be adjusted to control the depth of the cut. To cut a trench, the boom is held at a fixed angle while the machine creeps slowly. The chain trencher is used for digging wider trenches, such as for telecommunication, electricity, drainage, water, gas, sanitation, and others, especially in the rural areas. The excavated materials can be removed by conveyor belt, reversible either on the right or on the left side of the trencher. Next is Schema. These excavators are rigged using universal power unit for surface stripping and shallow excavation works up to 300 mm deep where a high degree of accuracy is required. They usually require a attendant haulage vehicle to remove the spoil and need to be transported between sites on a low loader. Because of their limitation and the alternative machines available, they are seldom used today. Next is dragline. These machines are based on universal power unit with a basic crane. actually rigging to which is attached a drag bucket. The machine is primarily designed for bulk excavation in loose soils up to 3,000 below its own track level by swinging the bucket out to the excavation position and hauling or dragging it back towards the power unit. Dragline machines can also be fitted with a grab or clamshell bucket for excavating in a very loose soils. Next, we have dumper. These are used for the horizontal transportation of materials on and off construction sites, generally by means of integral tipping skip. Highway dumper are a similar but larger design and can be used to carry material such as excavated spoil along the roads. A wide range of dumpers are available of various carrying capacities and options for gravity or hydraulic discharge control with front tipping, side tipping or elevated tipping facilities. Next, we have face shovels. These machines are sometimes called loaders or loader shovel, and their primary function is to scoop up loose materials in the front-mounted bucket, elevate the bucket, and maneuver into a position to deposit the loose material into an attendant transport vehicle. Tractor shovels are driven towards the pile of loose machine will enable the bucket to be filled. Both track and wheel versions are available, the track format being more suitable for wet and uneven ground condition than the wheel tractor shovel, which has greater speed and maneuvering capabilities. We have backhoe, the most common machine that we have on the site. Backhoe is mostly used where it is expedient to keep the loader at the original ground surface and excavate the ground from the subsurface below this level. The situation of this kind are the trenching, canal excavation, and building foundation works. These are available with the wheel as well as a crawler mountings. The mug can be loaded into a haulage unit or it can be cast at the site of the excavation. The backhoe boom is designed like excavator boom to achieve optimum digging performance and easy loading over trailer sites and obstacles. Next, we have roller compactor. There are many types depending on the type of soil and the capacity of the machine. The type of roller compactor that we have is smooth wheel roller, pneumatic wheel roller, sheep foot roller, vibrating roller, and tamping roller. For scraper, this machine consists of scraper bowl which is lowered to cut and collect soil where side stripping and leveling operations are required involving large volume of earth. When the scraper bowl is full, the apron at the cutting edge is closed to retain the earth and the bowl is raised for traveling to the disposal area. On arrival, the bowl is lowered, the apron opened and the spoil pushed out by the tailgate as the machine moves forward. Another bulk excavation operation, shallow cut and fill operation, occur in rockworks and airfield construction. Area of cut and fill can be adequately drained by temporary trenches, which the water will be drained into the final subgrade drainage. The formation level must be protected against water and the drying out action of wind and sun by some form of waterproof material. The third operation of bulk excavation is basement construction. It is also called deep pit excavation due to the excavation is over 4.5 meter deep. There are four methods of excavation for basement construction, which are open cut excavation, cut and cover techniques, top-down techniques, and composite techniques. For each technique will be briefly explained in the next slide. For deep explanation will be covered in chapter 5 for basement topic. These are the basic illustration for open cut excavation. and cut and cover techniques. And here are the method of top-down and composite techniques. We need to classify deep versus shallow versus medium excavation. For construction purposes, the term deep pit, which applies to excavation over 4.5 meter deep, is synonymous with the term basement. Shallow pit, 1.5 meter deep, present little or no problem in terms of excavation or ground support. They are normally excavated with small back-acting machine or by hand. Medium pits, however, classified as 1.5 to 4.5 meter deep, require careful selection of plant and ground support. The following are supporting methods commonly used by contractors in protecting the excavated areas. First, we have the unshort excavation, short excavation, dumpling methods, which we will look at it next, and cut-off walling method. Dumpling method or perimeter trench method is used where there are buildings or streets in the proximity or where weak soil are encountered. A trench wide enough to enable the retaining walls to be constructed is excavated around the perimeter of the site and timbered according to the soil conditions. The permanent retaining walls are constructed within the trench excavation and timbering is removed. The dumpling or middle can be excavated and the base cast and joined to the retaining wall. This method could also be used in firm soils where mechanical excavators required for bulk excavation are not available. The next method is cut-off walling method. The word cut-off is meant to define the specific purposes of this technology. For example, to either stop the flow to dam the underground stream or to the surround seal off an area. It creates barriers to groundwater flow. The common types of vertical cut-off walls are sheet pile walls, geomembrane walls, and slurry trench cut-off walls. There are considerations on the choice of support being used in basement construction for bulk excavation. On spacious site, an excavation can be benched or bettered. When excavating closely to property lines or nearby buildings, some form of slope support such as sheeting is used to retain the soil around the excavation. As the picture illustrated, with short excavation, the shoring can be made watertight by sealing the joint of sheet piling, thereby eliminating the free flow of water. The next bulk excavation techniques is hand excavation. This will occur in excavation which are heavily supported, leaving little room for mechanical excavation. It will also necessary in the vicinity of services, such as pipeline, which will be subject to damage by machine or by the case of removing obstacles such as boulders, logs, or other projecting objects. Spoil from each excavation would be put into skips for periodic removal. These are the examples of hand excavation. The second techniques of excavating is rock excavation. It depends on types of material that is being excavated, the quantity involved, the condition of the site, for example, the size of the site or any adjacent building nearby, and the equipment available. The example of techniques for rock excavation is breaking by hand using hammer and wedges, pneumatic breaker, drilling with pneumatic machine with the assistance of freezing liquids such as liquid nitrogen, and drilling with pneumatic machine by blasting. The first three methods are suitable where any of the following conditions prevail. The noise of blasting will cause annoyance. Adjacent buildings may subject to damage. Blasting may cause inconvenience or stoppage of traffic. Landslide or rock falls might result, and accurate cutting is necessary and excessive overbreak would be uneconomical. Another technique of excavating is trench excavation. Trench excavation is a narrow excavation primarily for strip foundation and buried services such as pipeline. Excavation can be carried out by hand or by machine. The choice of methods depends on purpose for which the trench is being excavated, the nature of the ground, the time scale of the work, the groundwater conditions and its level, the location of the trench, and number of obstructions on the site. There are three methods of trench excavation, which are full depth, full length excavation, full depth, successive stages of excavation, and last but not least, stage depth, successive stages. The first method for trench excavation is full depth, full length excavation. This method is suitable for long narrow trenches of shallow depth in which the machine completes the trench non-stop ahead of any other operation. This method is suitable for pipelines and sewers. The next method is full depth successive stages of excavation. This method is suitable for deep trenches where several operations of work can proceed in sequence. This would prevent stretches of trench from being left open for too long and thereby being subject to collapse. And the last method of trench excavation is stage depth, successive stages of excavation. This method is suitable for very deep trenches in confined areas or adjacent to existing property. It involves the support of trench as the work proceeds and is most suited for operations such as deep foundation and underpinning works. Another technique for excavation is support of excavation. The support of excavation is governed by the following factors, which are type of soil, groundwater condition, and depth and width of excavation. And it always depends on the soil types. We have the loose sand, gravel and silt, compact sand and stiff clays, and rock. For support for excavation in loose sand, gravel and silt, it requires some form of continuous support, which may consist of trench sheeting, which is the lightweight pressed steel sheets, and another one is steel sheet piling. Since such soil are likely to slump quickly, the support must be placed immediately after excavation takes place. This means that the deep excavation will have to be dug in stages. The first stage is being dug by machine, and after supporting the first stage by the trench sheeting or the steel sheet piling, the subsequent stages are by hand or by grab. Hand excavation is very expensive and therefore the use of driven sheet piles may be more suitable for deep trenching. The picture illustrates the trench sheeting, which is the lightweight pressed steel sheets. For the second type of soil, which is the compact sand and stiff clays, support for this type of soil can be achieved by using open timbering support. Involve the use of pulling board or trench sheet at intervals of approximately 1 meter The boards are supported by continuous walling and trenches jack at 2 meter center. If the soil is subjected to drying out and crumbling, the spacing of the pulling boards can be reduced accordingly. Dry clays may take up rain, water and expand. This will produce extra stresses in the struts, and allowance should be made for this at the design stage. For the last type of soil, which is rock, support to rock excavation depends to large extent on the type of rock and the slope of the rock strata. In the case of unstable rock faces, open timbering should be used to prevent any slump or collapse. Where the depth of excavation is excessive, the rock face may be stabilized by rock bolting. Rock bolting consists of solid steel rods which are fixed in deep drill hole by means of wedges, sleeves or grouting process. Like steel section or steel plates are used to support the rock face through which the rods are threaded. Support of these materials may be expensive. It may be more economical to cut this back to a safe angle of repose if space allows such treatment. This shows the illustration of rock bolting, and this is the view from the side face of the rock. The final techniques of excavating is embankment. Embankment is referring to a wide wall of earth or stones built to stop water from flooding an area or to support a road or railway. Construction of embankment and the design profile of the sloping side will depend on a number of factors. The first one is the purpose for which the embankment is constructed. For example, the loads that will be involved for the embankment. The consolidation of the fill in the embankment under the proposed load, because as we know, it will consolidate over time. The stability of the ground on which the embankment is to be constructed. The extent to which the strength properties of the fill may be affected by the method of construction. The cost of obtaining the suitable fill material and the difficulties in construction during adverse weather when using clays and fine sand especially. The construction of embankment will depend on the extent of the work, the type of fill material being used, and the nature of the site. The site must be stripped of all vegetable matter and foreign objects. Fill material should be tipped and spread in layers of such a thickness that can be compacted to the required density, which will be established by laboratory testing. In embankment construction, when large volumes of fill are involved, the density factors obtained in the laboratory may not be achieved on site. This is because only sample that is being used to test in the lab. Difficulties in varying the moisture content of large volume of earth between the two stages of excavating and filling. This discrepancy can be minimized by correct selection of compaction plant. The plant must be suited will depends on the soil type and its working moisture content. The safe angle of embankment slope will depend on the nature of the fill material used and the height of the bank. The safe angle will range from as much as 45 degrees for rock waste fill down to as little as 20 degrees for some clays. Slope may also be stated in ratios and percentages. For example, slope of 1 to 3 or 33% or a slope to 1 to 5 or 20%. These are the example of construction of access, embankment, and container terminal site. That will be all for today recorded video. Thank you for your attention. I will end the recorded video with a quote from Satya Nani. A little progress each day add up to big results. Thank you.